Gas welding. Perhaps the easiest and most common way to join several metal parts is gas welding. It's popular due to the fact that the equipment is simple, gas or welding mixtures are sold everywhere, and the energy source doesn't have to be high power. With gas welding, the metal is heated gently and slowly, so this joining method can only be used for conventional or tool steel, non-ferrous metals and cast iron. The thickness of the metal must not exceed 5 mm either. Pay attention to the white color of the flame. This means that a mixture of oxygen and fuel gas is used. The welding method shown in the video looks quite original. The flame flux is well adjusted and provides excellent adhesion. Friction welding. Friction welding is often used to join different metals and thermoplastics in the aerospace and automotive industries. It's a type of pressure welding in which two metal surfaces are joined by deforming the area in which they come into contact. In this particular case, one of the parts to be welded rotates or moves in relation to the other. Friction is then generated by this interaction, and it heats the contact area, resulting in direct welding. The process can be divided into 3 stages. During the first stage, the frictional force destroys and removes the oxide films present on the surface in the initial state. During the second stage, heat is released and the material becomes moldable under its influence. First, temporary contact occurs, but then it breaks. The parts are pressed with constant or increasing pressure, which causes the most moldable parts of the pieces to be welded to be extruded from the joint. Finally, the third step is the end of friction. It's completed by the formation of a welded joint. This welding method was first used in 1956, after which it was actively introduced into the industry worldwide. Hyperbaric welding. If you've ever wondered how underwater welding is done, you're about to see it. The main feature of this welding is that it's carried out at high pressure. Hyperbaric welding is applied when it's necessary to repair a ship, an oil platform, pipes, and other metallic structures submerged underwater. A special waterproof electrode adapted to these conditions is used in the welding process. If other equipment is used, there is a high risk of electric shock. The electric arc increases the temperature of the workpiece and the electrode. The melted metal is transferred to the workpieces by means of a gaseous bubble. It forms around the arc due to the disintegration of the flux layer on the electrode. The electric current causes the metal droplets to travel from the electrode to the surface to be treated, performing the welding process. It should be noted that the work must be done with care, and more importantly, quickly, as the joint cooling speed is higher in the water. Forge welding. This is the first technical process in human history to create inseparable metallic compounds. Studies of ancient metal objects have shown that people began to use forging in the 4th or 3rd millennium BC. Modern forge welding is mostly done with the help of hydraulic hammers and presses. This type of welding has practically no advantages. It may seem that the process is quite simple. The metal parts are heated until they become moldable, then the surfaces to be welded are covered and molded with the impacts from the tool. However, the process is far from easy. In fact, it requires a blacksmith with knowledge, experience, and high qualifications. Other disadvantages of this type of welding are low productivity and low strength joints as a result. Due to these characteristics, forging can only be done with a few metals. Nowadays, it's mainly used in adverse conditions when machine parts and equipment have to be repaired without being able to use complex technology. It should be noted that the parts must be of low-carbon structural steel. The carbon content should not exceed 0.3%, otherwise the weldability of the metal is drastically reduced. Electron beam welding. The first electron beam welding plant was created in 1958. Today, this equipment is widely used to weld refractory and highly reactive metals in the space and aeronautical industries, in instrument manufacture, and other similar fields. Heating and welding are possible thanks to the kinetic energy of the electrons produced by the beam. A special electron gun produces the beam. Electron beam welding is used when it's necessary to obtain a high-quality seal with deep penetration welding for large metal structures. Advantages of this method include the fact that in the process, the melted metal is not saturated with gases. In addition, the high heat concentration allows even thick metals up to 200 mm to be welded in a single pass. However, there are also disadvantages. The process must be carried out in a special vacuum chamber. In addition, the weld route may have lack of fusion. Submerged arc welding. This welding technique is used in stationary workshop conditions and can be used with any metal and alloys with a thickness of 1.5 to 150 mm. The welding is done by electric arc. It burns under the flux layer between the end of the welding wire and the metal to be welded. The electrode cable is automatically formed in the arc by special mechanisms. One contact carries the welding current to the wire and the other to the metal. This welding method shows higher productivity and minimal metal losses. In addition, the welding zone is protected to the maximum. Since the arc burns under the flux layer, there's no splashing and no need for protection devices against light. Laser beam welding. If you need to connect identical or heterogeneous metal parts for electronic or radio devices, most of the time you should opt for laser beam welding. As you can guess, the laser acts as an energy source. It was first used in the 1960s when the first continuous wave and pulsed laser systems appeared. The welding process is quite simple. The laser beam is directed to the focusing system, becoming a beam with a smaller cross-section and hitting the parts to be welded. Partially reflected, the laser beam penetrates the material. The metal then absorbs it, heating up and melting. This is how welding joints are formed. Interestingly, this welding method is much more environmentally friendly compared to traditional welding techniques. Exothermic welding. The powder mixture consisting of mill-scale and metallic aluminium or magnesium is called thermite. In exothermic welding, this powder is used to heat the metal. Aluminium-based thermite is used when it's necessary to bond steel and cast iron parts. In most cases, it's used to process rail and pipe joints, weld cracks, and weld overlay. The parts to be joined are processed with a refractory material, after which they are heated. The melted thermite is ignited and then used to fill the welding site. Thus, the liquid iron which is formed in the process melts with the main material, creating a strong weld. Magnesium-based thermite is used to repair telephone and telegraph wires and all kinds of cables. Hey, stop being lazy, it's time to use that brain of yours. Welcome to Brain Time, incredible facts from the past, the present, and even the future. the power of nature and wild animals, amazing facts and unsolved mysteries. You'll find all this and much more here. Subscribe now, you won't regret it.